The objective for this lab was to examine and predict the motion of a spring mass system, starting from rest, given a video of the motion. I found that the observed and the predicted motion matched up very well for both the X and Y positions, minus the fact that at the peaks, the observed motion is always less than what the predicted motion is. This may be due to miscalibration in tracker when I was taking in the position data, because if the calibration stick was a little bit too long, then the observed motion would appear to have smaller peaks than the predicted motion, as is seen here. The physics for this lab include needing to be able to calculate the spring force, knowing only the mass and the time, which you can use the equation shown for. And the fundamental principles being used in this lab are the energy principle and Newton's second law. Newton's second law is used to calculate delta V so that we can update the position of the spring, and the energy principle is used to observe the change in energy of the system. Using the position data that I was able to extract using tracker, I was able to approximate the period of oscillation of this motion, and it came up to be 1.613 seconds. However, I know this is off because if you look at this right here, it shows what the predicted motion would be versus the observed motion, assuming that the period really was 1.62 seconds. And as you can see, they are not in sync, and as time goes on, they become even further and further out of sync. So I calculated the period next based on Y, and it came out to be 1.522 seconds, and that's a much closer match, as you can see. The fact that using peaks and X values made a bad way for finding the period is most likely due to the nature of the motion, in the sense that the forces acting on the object in the X direction are constantly changing based on where the object is. As you can see, for this whole motion, the energy principle holds true because all the changes in delta U and delta K all add up in every point to give you a total of 0 total change in the energy of the system, which is exactly what the energy principle states should happen.